Let's talk about linear regression and how we find the equation for the line of best fit. Remember Galton's comments that he observed regression to the mean. What he was saying there was that when he was looking at parents that were very tall, their children seemed to be a little shorter than the parents themselves. They were a little closer to average height. And when he was looking at parents who were very short, their children tended to be just a little bit taller. They tended to also be closer to average height. He called that regression to the mean. When we measure x and y in standard units, what this means is that when we look at the line of best fit, so-called regression line, the deviation of y from 0 in standard units is less than the deviation from x in standard units. And it turns out that the equation for the line of best fit in standard units has this very nice form. It's y equals r times x, where y and x are both measured in standard units. Of course, this is not true for every point in our data set. It's really the equation for the line that best fits our data, and we'll explain what that means in a moment. How can we calculate the slope and intercept of the line of best fit? Well, when we look at the equation in original units as opposed to standard units, we get this complicated expression on top of the slide here. But we'd really like to re-express this in terms of the slope-intercept form for a line. Y equals slope times x plus intercept, where now y and x are both measured in the original units. This picture shows the connection between the measurements in standard units and the measurements in original units. Remember that in original units, if you have a value which is equal to the average of x, then in standard units, that value is 0. We know the equation for the regression line in standard units. It's y equals r times x, and so the y-intercept there has to be 0, and we expect the line of best fit to go through 0, 0, and to have slope r. And that's what we see on the left side of the picture. On the right side of the picture, we have to see the corresponding picture. And what we see then is that the line of best fit should go through the point which is the average of the x and the average of the y's. That's the point that corresponds to 0, 0. And then think of the slope in the following way. Think of one standard unit in the x direction as one standard deviation in the original units. And so that explains the base of the little triangle that we're using to demonstrate the slope. And it also explains the height of that triangle, because r in standard units on the y-axis is r times the standard deviation of y in the original units. In looking at the original units, you can see that we get the line whose slope is r times the standard deviation of y divided by the standard deviation of x. And we also can compute the y-intercept of that line, because we happen to know that that line goes through this average of x and average of y point. Here are the equations. If you want to write your line of best fit in the slope times x plus intercept form, then the slope of the regression line is r times the standard deviation of y divided by the standard deviation of x, and the intercept of the regression line is equal to, and this requires just a little bit of algebra, which we're not showing you here, but it's equal to the average of y minus the slope times the average of x. Here's a discussion question just to get our minds working before we switch over to the demonstration. Suppose we use linear regression to predict candy prices in dollars from sugar content in grams. What are the units of each of the following? Take a moment, pause the video, think about your answer, and then we'll resume in a moment. Okay, we're trying to predict candy prices. So if I'm imagining this line of best fit, the y-coordinates are candy prices and measured in dollars, and the x-coordinates are sugar content measured in grams. R, the correlation coefficient, that actually has no units. Remember that standard units don't have a unit measure, and so R itself has no units. The slope is the y coordinates units divided by the x coordinates units, right? And in this case, the units of the slope are dollars per gram. And the intercepts units are the y coordinates units, and in this case, that's dollars.